Okay, I will try to show you how to add trigonometric functions graphically and algebraically. Suppose we have to add 3 sine omega t minus pi over 4 minus 4 sine omega t plus pi over 3. Graphically, I'm looking for something. I have it here. So let's do it graphically. Maybe I'll try to do it on this. So we have 3. Let's see. This is 0, minus 45. Just a minute. Minus 45 degrees. It's about here. So we take three parts. 1, 2, 3. Okay, this is good. This is 3 sine minus here minus 60 degrees. 61, 2, 3, 4, 5, 6, 60 degrees, and we have 4. But in the other way, it means we have 4. 1, 2, 3, 4. Okay? So, the sum of the two vectors, or the two functions, will be something about here. So it's about this much. So this is the results. So it's about, I can tell you, the module is about 1, 2, 3, 4 and something. And the angle is about 88. Okay, let's try now to do it algebraically. So we first take this vector at t0, so the 3 here minus pi over 3, cosine is 1 over square root of 2, and the sine is negative, it's 1 over square of 2, minus 4. The vector or sine omega t at t0, this vector will have pi over 3, its cosinus is 1 over 2, is it correct? And square root of sine is squared. So we add the two, the real parts we add together. 3 over 2 minus 4 times 1, 2 times 2. This is 3 minus 3 over the imaginary part, 3 times this, and minus 4 times this, which is minus 2 square root of 3. Together, if we add them, the real part will be 0.12.13, and here we have minus 5.585. So the module of these results is 5.586, and the angle is minus 88.75 degrees. So if we want to write the result in instantaneous value of the current, it's this, minus 88.75 degrees. Okay, let's take another example. Suppose we have to add add V, this is a voltage, 5 sine omega t minus 3 sine omega t plus pi over 6. So at t0 we represent the vectors. We can do it graphically like we did before, quickly to see how it looks. We take 5 this way. Okay, I have 5. Just a minute. 1, 2, 3. What am I doing? Okay. Okay, we'll take centimeters better. 5 centimeters. Okay, I have 5 centimeters. And minus 3 pi over 6. Pi over 6, it's pi over 6 is here, 30 degrees. Okay, mame, we have minus pi over 6, and it is 3 centimeters. 3 centimeters, it's about here. Okay, so we see that the result will be 5, 1, 2, 3, 4, 5. The results will looks like this. Okay. Oh, it's about the angle is about 32 degrees, minus 32 degrees, and the module is about, here it's more than 3. Let's see algebraically how we calculate it. So let's tie the real part of this vector, 5, is 5, 0, minus 3. This, the real part is cosine pi over 6 is square root of 3 over 2. Sine is 1 over 2, so we add the real parts. Here we have 5 minus 3 over 2, and here we have 0 minus 3 over 2. Real part here will be 2.4 and minus 1.5 for the imaginary part if we use the complex numbers. So the module of this sum of the two vectors and the argument is minus 32. So if you have to write the result of the instantaneous voltage is 2.83, excuse me, because we are English, we should use point and not a comma. Point, and earlier is same thing, sine omega t minus 32 degrees. This is the result of the sum of two trigonometric functions, we can call them. We can take a second one, a third example, but I prefer, okay, let's take third example, 3 sine omega t plus 2 sine omega t plus pi over 6. So we have 3 here, 1, 2, 3. Graphically, let's see how it looks. And this is twice, 3 times, here twice, it means it's about like this. So if we add, we see, no, this one is about, if we, this is in centimeters, this is 12 and this is 16. Okay, so let's say it's about 4 and something. Okay, and the angle is about 12. So let's do it algebraically. So this is 3. This vector will give cosine is 1, sine is 0, plus 2. We know that the cosine of pi over 6 is square root of 3 over 2, and sine is 1 over 2. So the real part of the sum of the two phases is 3 plus square root of 3, and we have 1 here. So we can say that the result is 4, 7, 3, 2, and 1. So the result is the angle is about 12 degrees, and the modu of this vector is this much. Okay, so if we had to write, the result is 0.836 sine omega t plus 12 degrees. Let's take another example. I think now we try to do something interesting, because it's about three-phase voltages. This is very interesting. You remember we have three-phase voltages, V1, V2, and V3. And we want to do the difference, for example, of V1 minus V2, which is line voltage. So it means we have V, this is sine omega t minus sine omega t minus 2 pi over 3. Unit vector, okay? We can add the peak voltage here, Vm times sine omega t minus Vm sine omega. We'll do it for 1. So this vector, the real part is 1, 0, minus the real part of this is minus cosine is minus 1 over 2, and sine is negative as well, minus this. We add them together. Here we have 3 over 2, and here we have 2 together will be and this we know this is pi over 6, so the result is the modu is square root of 3, and the angle is pi over 6. So the result of the sum of the two vectors is square root of 3 sine omega t plus pi of 6. So if it was Vm and Vm, it will be, the results will be square root of 3 Vm sine omega t plus pi over 6. You see? Okay, let's do another one. Now let's try to make okay, we do V3 minus V1, V3 minus V1. So this is the sine omega t plus 2 pi over 3 minus sine omega t. The result is, we know that the real part is minus half, imaginary part square root of 3 over 2 minus 1, 0. The result is minus 3 over 2, we add the 2, and square root of 3 over 2, we can get square root of 3 out, and we have minus, and this is the angle of 150 degrees, and this is the result. So if we have to write V, this is sine omega t plus 150 degrees. So let's try last one. This is last one is, for example, V2 minus V3. So it means V equals sine omega t minus 2 pi over 3 minus sine omega t plus 2 pi over 3. You can do it graphically. Graphically, it means that this is minus this one. So it's square root of 3 and 90 degrees, I'm sure. So let's write minus over 2, the real part, imaginary part this much, minus real part for this angle, for this vector or complex number. This is like this is 0, like I said before, minus 2, this is 0, minus square root of 3, square root of 3 out, 0, minus 1, and this is 90 degrees, so it means that the module is square root of 3 and minus 90 degrees. So we can say that sum of the two vectors is square root of 3 sine omega t minus 90 degrees. Okay, thank you very much.